rain problem. When rain is falling, if we travel, if we ride on a vehicle, then even though the rain is falling vertically, it appears as though it is falling at some angle with the vertical. So that is known as apparent direction of the rain. This apparent direction changes with the speed with which we travel horizontally. Let us try to understand this with using vectors. If VR represents the rain vector, that is vertically downwards, Vm represents the velocity of man horizontally, then the relative velocity is Vr minus Vm, relative velocity of rain with respect to man. So velocity of rain minus velocity of man, that gives the relative velocity of rain. Minus Vm is opposite to Vm, that is shown at the bottom. That vector is written at the bottom. Then I have constructed Vr minus Vm. Minus Vm is constructed at the head of Vr. On the right side figure, you notice at the head of Vr, minus Vm is constructed. The vector from the tail of Vr to the head of minus Vm, the inclined vector, is the relative velocity vector. The relative velocity vector. If it is making an angle theta with Vr, then tan theta is equal to Vm by Vr. Tan theta is equal to Vm by Vr. In the form of vectors, we can write V relative is equal to Vr minus Vm. Relative velocity mathematical form is V relative is equal to Vr minus Vm. Remember that V relative, Vr, Vm are all vectors.